all we have left then is the one remaining side. So we want to compute F for D. Now, I'm not going to take you through the whole calculation. As you might suspect, there should be a very close relationship between FB and FD. Let's just take a quick look at this, and then we can wrap up the lecture. So to get the force on D, notice I'm going to be integrating here along this direction, right? So my little changes going along the flow of the current. I'm clearly going to slice and dice things in this direction. When I do that, notice I have an exact parallel. Every chunk on side B has a corresponding chunk on side D that has exactly the same length, the same current, and the same value of the magnetic field. So I think it's pretty clear each of these chunks gives me the same contribution, at least in magnitude. The only question might be the direction. To get the direction, remember, what you do is you take the direction of the current flow and you cross that with the magnetic field. So I want to take a downward direction. Imagine taking your right hand and orienting it so that your fingers are pointing down the page. Then you have to rotate your wrist. This one's also kind of awkward. You have to rotate your wrist until you find an orientation where it's easy to curl your fingers down towards the magnetic field. When you do that, you'll find that your palm, again, is facing downward with your fingers pointing downward. You stick out with your fingers pointing down along the page with your palm face down on the page. You then stick your thumb out. It points off to the right. So each little chunk of this integral along D has the same magnitude as the corresponding chunk along B, except the direction now is off to the right instead of to the left. So the force on D actually points in the plus I hat direction. But the magnitude is clearly going to be exactly the same. So that then gives me the final force. F of D is exactly F of B, except for the sign. So I'll have mu naught I1, I2 over 2 pi times the log of the ratio R2 over R1. And in this case, it is in just the plus I hat direction. The last thing I'll do just for completeness, because this was actually the statement of the problem, is to give you the total force. Now the total force is pretty simple to write down. Of course, FB and FD are exact opposites. They cancel. We just have left over A and B. But for A and B, you recall it's just this factor of mu naught I1, I2 over 2 pi times the length in the j hat direction with a 1 over R2 for plus j hat and a minus 1 over R1 for the contribution from side A. So there I have all of my factors, mu naught I1, I2 over 2 pi. The bigger of the forces, of course, is R1. So I have 1 over R1 minus 1 over R2. These all multiply the length of the loop L, and the final direction was downward, so this should be in the minus j hat direction. And if you want to check your sign, the R1 term I'm putting in the minus j hat direction, and indeed the R1 term was in the minus j hat direction. Checking my factors, mu naught, 2 i's and an L over 2 pi r, and I have mu naught, 2 i's, and L over 2 pi r, and then my direction. So that is the final total answer for the force on that particular loop.